Hi, welcome back to McClutchy Maths. My name is Natalie McClutchy and today we are finishing our PSMT series with video 12 on how to write a problem solving and modelling task for the 2025 Queensland syllabus. And we are looking in this video at the justification of decisions using mathematical reasoning. If you'd like to engage further with us here at the channel, here are some ways that you can go about it. Firstly, you could consider liking and subscribing. Hit that notifications bell, do it now. And that way you'll always know when the next video is available to watch. There's also some other ways you can engage with us. You can follow us on Facebook and on Instagram, or you could consider putting this on your OneNote, or even tell us in the comments if you found the video helpful. There's a new feature on YouTube called Thanks, Super Thanks. It's indicated by a little love heart button. And I'd just like to shout out to our super fan, Jason T, who has made several donations to us. We really appreciate it here at the channel. It's just a short $2 donation, and that will help us with the running costs of the channel, which there are many, as well as to supplement some of the expenses. All right, let's get straight into that. Our instrument-specific marking guide, the ISMG, we are in the section on communicate, and we're looking at the justification of decisions using mathematical reasoning. Now, this used to be in our evaluate section. It's moved to the communicate section. And if we don't hit up here, we are going to hit in the 1 to 2 range with statements of relevant decisions, or a statement about it. You'll notice the difference here is that these ones here are justified, these ones are not justified. This one here has a plural of decisions, and you should be making more than one in your assignment. And this one here is just a single decision. This one here is using mathematical reasoning for the justification, and these ones down here are just relevant decisions. And if you don't make any decisions in your assignment at all, it will be in that 0 range. Okay, you might be thinking, well, what decisions do I make in my assignment? I don't think I've made any. Well, chances are you've made quite a few. Some of the key decisions you could be making are things like about a sample. If you had to come up with the sample yourself as part of an experiment or a study, then the method that you chose your sample parts for is one of the decisions. The sample size that you selected, whether you selected 20 or 100 or somewhere in between, whatever size you chose should have a mathematical reason why you chose it. That's a key decision. If you chose to compose your sample of certain elements, that is also a decision you made. So for example, you might decide, if you're doing an assignment on houses in a particular area, you might decide to only do 4-bedroom houses to keep your study consistent and remove confounding variables. That might be your decision. You have to justify the decision. Why did you choose 4 bedrooms? Why not 3 bedrooms? Why not 3 or 4 bedrooms? You've made a decision, you need to justify it. You may have made a decision later in the assignment about what kind of model you were working with, whether it was linear, quadratic, or exponential. You may decide a particular type of graph to represent your data. That's another choice you're making that should be justified with your mathematical reasoning. You may have made a decision about which variable you're going to graph on the x-axis, your independent variable, and which variable you're going to graph on the y-axis, that's your dependent variable. Why did you choose to put that one on the x and the other on the y? That should be something you should explain. Otherwise, it's just a statement. You may have decided to eliminate or exclude certain variables. So as we mentioned before, with the 4-bedroom house, you may have decided to only include ones in a particular suburb, or only include houses on a particular street. So that means you've excluded a whole lot of other variables. Why did you make that choice? You need to explain it. You may have discovered outliers as part of your study, and you may have made the decision to keep them in the data or to exclude them from your data. Either way, whatever you choose, you've made a decision. So you need to describe and explain why you kept the outlier in, or what impact it has, and why you decided to exclude it. You may have made a judgment based on some calculations or some evidence. So that judgment is part of your evaluation at the end of your assignment. It could be the answer to the question the assignment's asking you to find out the answer for, such as how tall a building was, or do Australians drink enough water? That's the question you've had to investigate. And at the end, you're going to have a result, a yes or a no, or an answer that's a number. That judgment needs to be justified. You may have also decided on a particular way to round or to estimate answers, and that particular technique is another decision that you've made. So let's talk now about how to justify those decisions. We've given this definition right across several of our videos now, because justification is a big feature of the PSMT in 2025. So this is the QCAA's definition: to give reasons or evidence to support your answer, your response, or your conclusion, to show or prove how an argument, statement, or conclusion is right or reasonable. So up here, we're giving reasons or evidence to say why we made a particular decision. So that's that part there. That's the focus for this particular video. Now we've got this new placement in the communicate section of the assignment. This makes sense because decisions are right across your PSMT. Under the older syllabus, it was in the evaluate section, and that meant students felt like they needed a subheading to relate to it, whereas decisions are actually made right across the assignment from the very beginning of when you start. So in your formulate section, you're deciding which variable to graph where. That might be an example of a justified decision here. They've selected odometer reading as an explanatory variable because it can be assumed that, and they've gone on to explain that reason using mathematical reasoning. That is in the formulate section. Or you could see it in the solve section, such as the result of 0.302 is close to 0, indicating positive weak correlation. So this is from the QCAA exemplar. They've given a reason why this is weak correlation, because it's close to 0. So therefore, that is justified in the solve section. You can also see this in the evaluation section. This is where a student has looked at their residual plot and they've decided that because there's random scatter, then the relationship is linear. And this also comes from a QCAA exemplar, and they've then made a conclusion that this is appropriate for the study. So this part here is a justified decision using mathematical reasoning, that random scatter. So mathematical reasoning also includes language that explains and elaborates on your decision using a mathematical reason to support it. And that reason being mathematical is very important. So here I can see a student has talked also again about correlation. They've got moderate, negative, linear association. And they had also included a little table where you could work out where this particular one fitted. It fitted in this range. So that was mathematical justification or reasoning. Okay, showing all your steps of working also supports your mathematical reasoning and the justification of your decisions. So here, for example, a student has made a decision about time using calculus in the methods particular exemplar that they've put together. Because they've shown all of that mathematical working, that justifies the decision at the end here, which was the crux of the assignment. So that is included there. Mathematical reasoning also could include the explanation of a process and why you undertook it. So this also comes from the General Maths QCAA exemplar, and they've given a big explanation here about the residuals and whether it's an appropriate model to use because of the random scatter. So you can see that this justification of decisions can be presented in a number of different ways. When we're using our mathematical reasoning, it could be to verify a process. So here they've talked about using Desmos and the calculus procedures and what their purpose is. It's an efficient way to visualize how the parameters transform an equation. So in this particular case, that's also mathematical justification. The mathematical reasoning could include supporting your claims with a quote. So here I've got an example from the QCAA exemplar as well, where they've talked about how most boys reach their full height by the age of 16, and they've supported that using a quote. So that's part of their justification. Here are some more examples that I've dug up. This is also from the QCAA exemplar. I have justified my decisions purely based on calculations and hope I haven't made any mistakes in my thinking. Well, that is not mathematical justification for your decisions at all. There's no maths around that. So it's just a decision that you've made, a statement of decision. So when you write those decisions, preferably do it when you're writing the decision. Talk about the decision at that particular stage, not just at the end. Justify it as you're going. Here's another one from an example of a student's work. Systematic sampling was chosen to be used because it's easier to explain. Once again, this is not mathematical reasons. It's just because a student liked that method. They think it's easy to explain. It's just a statement of a decision made, not a justified mathematical reason. A student said a sample size of 30 cars was chosen to be suitable with every second car chosen. So what they've told you is the sample size and how they selected the sample, but there's no mathematical reasoning around that either. There's no justification of that decision. Here's another example from a student. Let X be the explanatory variable and let Y be the price. Once again, no justification. It's just a statement without a reason. They didn't say why this one was selected as the x-axis and why this one was selected to be graphed on the y-axis. So lots of examples here of things not to do. This figure is a scatter plot created in Microsoft Excel excluding outliers. There were 4 outliers identified. They have been removed. By removing the outliers, the R-squared value has increased. There's a mathematical reason right there. It makes the data more valid and improves the goodness of fit. So once again, they've used mathematical justification. There is a reason behind it and it's maths related. Well, I hope you found this video helpful today. It was a quick one, but hopefully a useful one. If you've got any questions about anything you've seen or heard, mcclutchymaths@yahoo.com is the place to reach us. My name's Natalie McClutchy. Have a wonderful day.